Welcome back to the ATA Chapter Channel. In Part 5 of our deep dive on the A380's ventilation, we're going to move past the main cabin and look at the specialized subsystems. These are the ones that handle some very specific and, frankly, absolutely critical tasks all over the aircraft.
So, you have to wonder, right? On a plane this massive and complex, how on earth does it keep its electronic brain from frying, or keep the galleys from getting smelly, or make sure the cargo is kept at the right temperature? Well, in this explainer, we're going to answer all of that by looking at 5 crucial systems: the avionics cooling, the galley and lavatory extraction, cargo ventilation, and even the systems for unpressurized areas and the in-flight entertainment center.
Okay, let's dive right in with what is, without a doubt, one of the most important systems for flight safety, the Avionics Ventilation System, or AVS. And its job, to put it simply, is to stop the aircraft's electronic brain from cooking itself. The whole point of the AVS is pretty straightforward. It has to protect all the vital electronics. You know, the computers, the controls, the flight displays, all the important stuff. It pushes a constant stream of cool, temperature-controlled air through the avionics bays and up into the cockpit, making sure every single component stays well within its happy operating temperature. So how does it do it? Well, it uses a really effective push-pull method. You've got the blowing subsystem, which actually has 2 totally separate circuits pushing clean, filtered air onto all the equipment. And at the exact same time, you have the extraction subsystem pulling all that air back out, taking the waste heat with it. It's a simple concept, but it guarantees a constant, complete circulation of cooling air. And here we can see the actual hardware tucked away in what they call the triangle area in the forward cargo hold. You can easily spot that big cylindrical filter that cleans the air, the fan that does all the hard work. And then there's that little guy right there, the backup valve. It might look small, but it is absolutely essential. Let's talk about why.
So, the big question is, what happens if one of those fans fails? This is where the system's smarts really kick in. There's a special sensor, a cooling effect detector, that's always monitoring the airflow. If it senses any trouble, it instantly sends a signal to the controller, which automatically pops open that backup valve. This gives the system a whole new source of air straight from the main AC mixer unit, making sure those avionics never lose their cooling.
All right, we've taken care of the electronics. Now let's shift gears to a system that you as a passenger would definitely notice: the Compartment Air Extraction System, or CAX for short. This is all about cabin air quality. The CAX system is a real workhorse. I mean, its most obvious job is keeping the cabin air fresh by pulling out odors and heat from all the galleys and lavs. But it's got a second job that's just as important, even if you can't see it. It provides cooling air for a whole bunch of electronic components scattered around the cabin. And just look at this list. It really shows you how much this one system does. It's actually split into 2 parts: a forward and an aft system. And between them, they're cooling power distribution boxes, creating air curtains at the stairs to stop smoke, cooling the rear avionics bay. They even pull air over the temperature sensors to make sure they get an accurate reading. Pretty impressive, right? And here's what the gear looks like installed way down in the bilge of the aircraft. On the left, you've got the forward extraction fan, and on the right, the aft isolation valve. And see those shock absorbers on the fan? That just tells you this equipment is built tough. It has to be, to handle the vibrations down in that part of the plane. Now this is just brilliant energy-saving design. When the plane's on the ground, the fans are running, actively pulling air out. Simple enough. But in flight, the system gets clever. It uses the natural pressure difference between the inside of the cabin and the outside. The valves just open, the fans turn off, and the higher pressure inside literally pushes the air out all by itself. The fans only kick back on if that pressure difference drops too low. Next up, let's head downstairs into the lower deck and take a look at the system that keeps the cargo safe and sound. So the bulk cargo compartment gets its very own ventilation and heating system, and it works by suction. A fan pulls air from the passenger cabin down and through the cargo bay, then vents it overboard. And this creates a slightly lower pressure in the cargo area, which is a really neat trick because it means any smells from the cargo are trapped down there and can't possibly drift up into the cabin. Now, a schematic like this can look a little intimidating, but the chain of command is actually pretty simple. The main aircraft computers, the CP-IMCMBs, are running the whole show. They send commands to a smaller, dedicated controller, the ventilation control module, and that module is what directly tells the valves, the fan, and the heater what to do. When the system needs to add heat, it uses a big electrical duct heater. But of course, you can't just let that thing run wild. There are a ton of safety features. A sensor keeps the air from going above 70 degrees Celsius. If it hits that mark, the power is reduced. And if it ever gets to 80 degrees, the whole thing shuts down and a warning is sent. A second sensor inside the compartment itself helps the system fine-tune the temperature perfectly. It's worth a quick mention that there's an optional heater for the main aft cargo compartment, and it works a little differently. Instead of having its own electric heater, it basically piggybacks on the main trim air system and just blends in some hot air when it's needed through a special valve. All right, we're on the home stretch. Let's wrap things up by looking at a couple of other specialized systems that take care of some unique spots on the aircraft. Not every solution has to be complicated. There are parts of the plane outside the pressurized cabin, like the wing roots, that still have equipment that gets hot. So how do you cool them? Well, the solution is beautifully simple. In flight, they just use these special vents called naked inlets. The plane's own speed forces air into these scoops and directs it right where it's needed. No fans, no power, just pure, simple aerodynamics. And finally, we have the in-flight entertainment system. That giant rack of equipment that powers all your movies gets incredibly hot, so it needs its own cooling. It normally gets its air from that same triangle area we talked about with the Avionics, and just like the Avionics, it has a backup air supply in case its main fan ever quits. And this brings us to a really critical piece of logic. What happens if the flight-critical avionics and the non-essential entertainment system both need that backup air at the same time? Well, the aircraft has to make a choice, and really, it's no choice at all. Flight safety is everything. The avionics always get priority. The IFE system's backup valve will be forced shut to make sure the aircraft's brain gets all the cooling it needs. So there you have it, a quick tour of 5 specialized systems all working behind the scenes. We've seen how the AVS is like a bodyguard for the plane's brain, how the CAC system is the unsung hero of cabin air quality, and how even the cargo and entertainment systems get the precise environments they need to operate. We are almost at the end of our journey through ATA Chapter 21. Make sure you join us for our final installment, where we'll cover some really unique supplemental cooling systems and take a look at key maintenance practices for all of this equipment. Thank you for watching. Please don't forget to like, share, and subscribe to ATA Chapter for more technical training. Join us for our final installment, Part 6, where we cover supplemental cooling and maintenance.